In this video, we're going to learn how to solve polynomial equations using factors. So we're going to find the real or imaginary solutions of each equation by factoring. So in order to do this, we need to move all of our terms to one side so that they're equal to 0. So that way we can use the zero product property. So first I'll subtract 3x, give me 2x cubed minus 5x squared minus 3x equals 0. And now I'll look for any common factors that I can factor out. So they all have an x in common, so I can factor out x, which gives me x times 2x squared minus 5x minus 3 equals 0. And now I have two factors being multiplied together that give me 0. So I can set my first factor equal to 0 and my second factor equal to 0. Now, the left factor x equal to 0 gives me one solution already, but the right one still needs to be factored more. So in order to factor this, I need to find two numbers that multiply to negative 6 but then add to negative 5. That would be negative 6 and 1. So I'll put minus 6x plus x and then minus 3. And then once I do this, I can group to continue factoring. So again, to repeat, 2 times negative 3 is negative 6. So negative 6 times 1 is also negative 6. And then negative 6 plus 1 is negative 5x. And that's how I got those two numbers. So now I'll group and factor. So group them 2 and 2. The first group has a 2x in common, so I can factor out a 2x. And when I do so, I'll be left with x minus 3. And the second group doesn't have any common factors, so I'll just keep it the same, and it's left as x minus 3. So the common factor is x minus 3, so I can factor that out. And when I factor it out, I'm left with 2x plus an understood 1. So I can set each of those factors equal to 0. And I'll get x equals to 3 as another solution. And 2x plus 1 equal to 0 gives me x is equal to negative 1/2 as the other solution. So this equation had 3 solutions that could work. And I could go back through and plug them all in, and I would get a correct statement for each of those equations. Now let's look at this bottom left example. So again, everything moves to one side first, so it's equal to 0. I'll subtract 6x cubed, so that gives me 3x to the 4th minus 6x cubed plus 12x squared to keep it in standard form. Now I can factor out a common factor, which looks like 3x squared. And when I factor that out, I'm left with x squared minus 2x plus 4. Now I can set each of these factors equal to 0. So 3x squared is equal to 0, and x squared minus 2x plus 4 is equal to 0. Now I can divide by 3, still have 0, and then I can take the square root of both sides. So gives me the absolute value of x is equal to 0. So x is equal to the plus and minus of 0, but 0 is neither positive nor negative, so I just get 0. So that's one solution. And one thing to definitely point out about this solution, it came from an x squared, that factor x. So that factor x comes up twice, so this 0 has a multiplicity of 2. So technically got that solution twice. On the right here, I need to solve this. Now I'm looking for two numbers that would multiply to 4, but then add to negative 2. But that's not possible. So this is not a factorable quadratic. So I need to use a different method to solve it. And I'm going to use the complete the square method, which means I need to subtract 4 from both sides. And then I need to find what number I need to add to the left side to make a perfect square trinomial, which is half of negative 2 squared, which is just negative 1 squared, give me 1. So I need to add 1 to each side of my equation. So on the left side of my equation, I have x minus 1 squared is equal to negative 3. So to finish solving this, I'll take the square root of both sides, giving me the absolute value of x minus 1 is equal to this is not a perfect square, but it's a square root of a negative number. So now we have an imaginary solution. So to finish solving this, I'll take the plus and minus of the right side. So x minus 1 is equal to plus or minus I square roots of 3. Adding 1 gives me 1 plus or minus I square roots of 3. So my other two solutions besides 0 is 1 plus I square roots of 3 and 1 minus I square roots of 3. So the importance of factoring is that we'll find these imaginary solutions if they exist for the polynomial. So right, this is already factored. So I can set each of these factors equal to 0 to start solving. Now I could continue to factor because this is difference of squares and also sum of squares. But instead I'm just going to solve for x since it's already there. So I'll have x squared is equal to 1, and I can take the square root of both sides. Give me the absolute value of x is equal to 1. So x is equal to plus or minus 1, giving me x is equal to 1 is one solution, and x is equal to negative 1 is the other solution. Over here I would subtract 4, give me x squared equals negative 4, take the square roots. That gives me absolute value of x is equal to, now this is an I, because it's the square root of a negative, but square root of 4 is 2, so I'm left with 2i. Now to get rid of the absolute value, I'll take the plus and minus of the right side. So my other two solutions would be x is equal to 2i, and x is equal to negative 2i. So I have 4 solutions for that equation, 2 of them being imaginary, so you wouldn't even see those solutions on a graph or using a graphing calculator. For this last example, I'll move everything to one side. To start, so I'll have x to the 5th. This is my 5x to the 4th term, so minus 5x to the 4th. And then plus 2x cubed give me plus 6x cubed. They have a common factor of x cubed. When I factor that out, I'm left with x squared minus 5x plus 6. And x squared minus 5x plus 6 is factorable. So that gives me x cubed times x minus 2 times x minus 3, because those negative 2 and negative 3 multiply to 6, and negative 2 plus negative 3 adds to the negative 5. So now I have 3 factors I can set equal to 0, with the left one, just like we saw earlier, having a multiplicity of 3. So x equals 0 with a multiplicity of 3. X minus 2 equals 0, and x minus 3 equals 0, giving me 2 and 3 for my other solutions. Now, in this top right example, I didn't continue to factor, but in the next video, I'm going to show the importance of always trying to factor as far as possible before you resort to this technique. This was safe because it was just x squared, and we typically get those 2 solutions when we take that square root. But you'll see an example in the next lesson why we want to maybe factor as far as possible to get all of the solutions. And that is how you solve polynomial equations using factors.